All right, in the last section we're going to do in section 3.6, the last kind of derivative we're going to look at is the derivatives of inverse trigonometric functions. Now remember, an inverse function is any function that will undo a given function. That's kind of a general definition. So remember, if we have some function f where we plug in some value a and get some value b, then an inverse function is where I take that value b that I got out of the first function and it gets me back to my original function a. Now the big inverse functions we're going to be looking in this section are inverse trig functions. So if you recall from pre-calc, the sine of pi over 4 is the square root of 2 over 2. So the inverse sine, which we denote with sine with a little -1 up there, radical 2 over 2 would be pi over 4. Now there are some restrictions on this. There are restricted ranges for inverse sine and things like that. But in general, for angles between -pi over 2 and pi over 2, this will hold. So we have this function that's going to undo a ratio to give us an angle, which is the opposite of a regular trig function, which takes an angle and gives us a ratio. So each of the inverse trig functions have a derivative, and they are listed here. So you can look at the rules. They're pretty different. The derivative of the arcs of the inverse sine is 1 over the square root of 1 minus x squared. And this is just a general derivative. Obviously, you can have chain rule and everything else with it. I did want to mention that another way that this is sometimes written, instead of writing it as sine with a little -1, a lot of times you'll see it written as arc sine of x. That is the same thing. So if you ever see the ARC in front of one of our trig functions, that's basically denoting one of these inverse trig functions. It's an older notation, but it really is still used a lot in calculus. And I think I even put some problems. I wrote the arc notation instead of this inverse notation. You'll notice the derivative of the inverse cosine is the same as sine, except for it has a negative sign. And that's actually true for all of these. All of the derivatives are pretty much the same, except for they're off by a negative sign. So really the ones that we usually think about are sine, tangent, and secant, because those are the positive ones. The derivative of arc tangent, which is a big one, is going to be 1 over 1 plus x squared. And arc secant is a weird one, arc secant and arc cosecant, because the derivative is going to be 1 over the absolute value of x times the square root of x squared minus 1. And this will actually be really helpful when we do some the second part of calculus and integration. These little things on the bottom really are really important. And you'll notice one is 1 minus x squared, one is 1 plus x squared, and one is x squared minus 1. Those are all the ways you can arrange x squared and 1 with a plus or minus sign. So that's very important. That will be something that will come up later on. But those are our derivative formulas, so we'll just do some practice using those formulas. So this first one I have the derivative of just 3 arc sine of 2x minus 1. Now, unfortunately, this has an inside. It has 2x minus 1. If we remember what the derivative of the regular arc sine, I'm just going to write that here so we remember. That's going to be 1 over the square root 1 minus x squared. Well, unfortunately, we have this inside, so our outside function we're going to think of as 3 arc sine of something. So the derivative of arc sine is going to be 3 times the square root of 1 minus something squared. Remember, if it was just x, we just put an x in there, but it's something different in this case. In our case, it's 2x minus 1. So inside those parentheses, we'll have to put the 2x minus 1. And then because it's something other than x, the chain rule applies here. So we'll have to multiply by the derivative of 2x minus 1, which is just 2. Because the derivative of 2x is 2, and then -1 just goes away. So our final derivative for arc sine of 2x, 3 arc sine 2x minus 1 will be 6 over the square root of 1 minus, and you can just keep this as 2x minus 1 squared. You are certainly welcome to expand it out, but you don't have to. So the big thing is just using that chain rule. Remember, if it's something other than x, we have to put that something in our derivative and then multiply by the derivative of that inside function. Now this next one, we have x times the arctan of x. So this has a whole nother problem involved in it. So this is going to be a product rule problem because we have f and g, two functions multiplied together. So remember the product rule is f prime g, g prime f. And just to remember from the first page, the derivative of the arctangent is 1 over 1 plus x squared. So when I'm doing this, so the product rule says, all right, so y prime dy dx first says take the derivative of f. Well, f is just 1, so that's easy. Or f is x, so the derivative is 1, times the arctangent of x plus g prime. Well, g prime is the derivative of arctan. Well, arctan is this whole derivative that we wrote above, times f, which is x. So what you end up with is the arctangent of x, or the inverse tangent of x, plus x over 1 plus x squared for your derivative. And there's not much you can do for that. That's pretty much as far as that derivative is going to go. The nice thing about it is there was no chain rule. It was just a straight product rule. We had a first function times a second function. If you were to have something in this arctan function other than x, then you would also have to do a chain rule kind of problem. All right, now this next one, you'll notice that we do have that kind of issue because we do have two functions and they now have something inside of them. Now, good news is, remember the arc sine formula that we talked about earlier, the derivative of arc sine of x is 1 over the square root 1 minus x squared, but arc cosine is just going to be the opposite of that. It's going to be negative. So if I want to find the derivative of this, the derivative of arc sine is 1 over 1 square root of 1 minus something squared. Now I say something because it's not just x in this case. In this case, it's 2x. And so I have to make sure whatever's in that function stays in that function. And then by the chain rule, I'm going to also multiply by the derivative of that inside function. So I'm going to multiply by a 2 because the derivative of 2x is 2. Plus, now the derivative of arc cosine is just this function with a negative sign. So we get negative 1 over the square root of 1 minus something squared. And in this case, it's going to be 2x again. And then we have to take the derivative of 2x, which is 2. So if you notice, these two functions are actually opposites of each other. One is positive, one is negative. Everything else is the same. So the derivative is actually 0. Now, there's some reasons why this is true. It actually goes back to the whole sine squared plus cosine squared equals 1 idea from pre-calc, but using the algebra, finding the derivative of each, adding them together, in this case, they happen to be opposites, so the derivative is just 0. All right, let's go ahead and look at a couple other ones, a little more complicated ones. So in this case, you can see this first one, we have h of theta equals natural log of theta squared plus 5 minus arc secant of sine theta. So the log and the arc secant are subtracted, so we can kind of do them separately. So no product rule or anything in this case, so that's good. So h prime of theta, so remember the log, when you do the derivative of a log, it's always 1 over whatever's in that log, so 1 over theta squared plus 5. But then the chain rule says we have to multiply by the derivative of theta squared plus 5. So theta is just like a variable, so it's like 2x, 2 theta, 5 goes away. So that's the first part. Now for arc secant, we have to remember what the derivative of arc secant is. So let's just write that up here. So arc secant of x derivative, it's that weird one. It's 1 over the absolute value of x times the square root of x squared minus 1. So kind of a bizarre one. So when I'm taking the derivative of arc secant, it's going to be 1 over. Now typically it's x there, but it's going to be something else for us. And then it's the square root. It's typically x, but it's going to be something else for us. So it's going to look something like that. So that something, remember, the something for our arc secant is the sine. The sine's what's inside it. So everywhere I see the x, I'm going to put sine instead. So you just replace the x with sine. And now the other trick, of course, if it's not just x, we have to use the chain rule. So I'm going to multiply by the derivative of sine, which is going to be cosine. So I just always multiply the derivative on top because it's just multiplied to the whole expression. So our h prime of theta, if I clean it up a little bit, is 2 theta over theta squared plus 5 minus cosine theta over the absolute value of sine theta times the square root of sine squared theta minus 1. And I am not going to simplify that because that's as good as it's going to get. So again, you're just trying to fill in those gaps for the inverse trig functions. Really nothing to it as long as you know the basic formulas. All right, let's try one more. And I try to put a hard, this is a really hard one because it's got a lot involved in it. We've got x times the square root of 4 minus x squared. So I can see right away we got a product rule here. And then we have 4 arc sine of x over 2. So we've got an arc sine with something inside, nothing too complicated, but something inside. And I did this one because you'll see that these sometimes will work themselves out to be something nice. So what I would do first is I would probably just distribute that half just to get it out of here. So we have x over 2. And then this is going to be 4 minus x squared to the 1/2 power. Because it's just easy, because you know when you take derivatives, it's easier to use the fractional powers. Minus, well, it's not going to be 4. It's going to be 2, because I'm distributing this 1/2 to both, because it's outside of all. So it's going to be 2 arc sine of x over 2. Now again, I didn't do any calculus yet. I've just started to set up the problem. So the first part I think is going to be the hardest, this product rule. So when I do that, remember the product rule, f prime g plus g prime f. So the derivative of f, well, f is just x over 2. So that's just going to be 1/2 times 4 minus x squared to the 1/2. That doesn't change much. Plus g prime. So that's going to be 1/2, because I'm bringing the 1/2 down, times 4 minus x squared to the minus 1/2. So I'm just taking this half down out front, and then I'm taking one less power. But since there's something inside, there's a 4 minus x squared, I have to multiply by negative 2x from the chain rule, because the derivative of the inside is negative 2x. And then I still have to multiply by f. And f, we said, was x over 2. So what a nightmare that is. Now, as far as the arc sine part, we could do the arc sine part. Remember, arc sine's derivative is going to be 1 over square root of 1 minus something squared, or 1 minus x squared. So in this case, we'll have minus 2. It's going to be square root of 1 minus whatever's in there. So it's 1 over x over 2 squared. But then we have to multiply by the derivative of x over 2, which is going to be 1/2. Because remember, this is like 1x over 2. So if I take the derivative of that, it's just going to be 1/2. So this is the nightmare I'm left with. So dy dx equals, let's just kind of write it out. So we have square root of 4 minus x squared over 2, because I just turned the half back into a square root, Now this one's a little trickier. So I can cross out these 2's. So I see I have negative x squared because I have these two x's multiplied together. So I have minus x squared. I also have a 2 on the bottom here. And this is an interesting fact. When you have a negative power, remember, we can take that back to the bottom. So that's 2 over radical 4 minus x squared. Here the 2's cancel, so this is going to be minus 1 over square root 1 minus x squared over 4. So there actually is more simplifying we could do with this, but this is pretty horrible as it is, so we'll just stop here. So just wanted to show you, we get to review the product rule, we get to remember kind of our square root rules, our chain rules. So this has actually kind of quite a few things as we finish up our derivative rules. Good news is these are all the derivative rules. We've done them all. Product rule, chain rule, quotient rule, the trig functions, the inverse trig functions, implicit differentiation, logarithmic differentiation. We've done them all. From now until the end of the year, we will learn no more derivative rules. So we just have to learn to master them and know when to use which rule. All right, so that's all for this section. Obviously, if you have questions, let me know.